Hello, and welcome to this presentation, Getting Started with the CMA180 POLQA Testing. In this presentation, we'll explain how to configure and use the Rohde Schwarz CMA180 radio test set to measure voice quality using the POLQA algorithm. This presentation assumes a basic familiarity with both voice quality testing and POLQA. It also may be helpful to understand the concept of frequency ID versus frequency in systems that use 8.33 kHz channel spacing. If you're unfamiliar with these topics, or if you'd like a brief review, you might want to watch the presentation Understanding Voice Quality Testing and/or the presentation Understanding 8.33 kHz channel spacing before beginning this presentation. The Rohde Schwarz CMA180 radio test set can perform audio quality tests using the POLQA algorithm when equipped with license option K122. Option K121, audio playback, is also required, and the VoIP option, CMA K610, is required if testing POLQA using VoIP interfaces. The CMA tests POLQA by simultaneously sending and receiving audio as modulated RF, as AF or audio frequency signals, and as a payload of VoIP packets. In most cases, testing involves a radio which converts between modulated RF signals and VoIP-encoded audio. Regardless of which interfaces are used, the POLQA algorithm compares the degraded or received audio with the reference or transmitted audio in order to compute a MOS value. Note that this process occurs entirely within the CMA180 without the need for any external hardware or software. POLQA testing can be grouped into three general types of scenarios. In a TX or transmit test, the CMA sends VoIP packets to the device or network under test and compares the audio in these transmitted packets to the demodulated audio from a received RF signal. A RX or receive test is similar, except that in this case the CMA transmits an audio-modulated RF signal and receives VoIP packets containing the degraded audio. The third scenario is a more generic audio test, in which analog audio frequency signals are used either as the transmitted signal, the received signal, or both. In this presentation, we'll go step by step through the TX and RX scenarios using a Rohde Schwarz S5200 series air traffic control radio as the device under test. But in the interest of time, we won't be covering the audio test scenario. Let's start with how to configure an S5200 series radio to support VoIP connections and POLQA testing. Note that the configuration will be the same for both the TX and RX test scenarios. The first step is to connect to the S5200's web-based management interface. This is accessible via the front panel LAN interface or via one of the LAN interfaces on the rear panel. Note that a username and password are required to access the management interface. Our next step is configuring the interface over which the S5200 will send or receive VoIP packets. This is done under the Configuration IP Network tab. Note that most configuration tasks require both write and expert access to be enabled. Select one of the rear panel LAN connectors, LAN 1 through LAN 4, and then use More Details to enter the IP address, subnet mask, and gateway for that interface. Note that this interface must be IP reachable from the CMA180 LAN interface, and this is most often done by configuring both interfaces to be in the same subnet. In our example, we've assigned address 192.168.1.119 to the LAN 1 physical interface. Next, we need to go to Configuration Radio to configure the radio parameters. The transmit frequency and channel spacing should be set or verified. In this presentation, we're using a UHF band radio, but for VHF band radios, the frequency is set using an ICAO channel number. In either case, it's important to make a note of this information, since we'll use these values to configure the frequency ID on the CMA180. Further down, we need to verify that supported audio interfaces is set to analog and VoIP. The last set of parameters are found under the Configuration Audio VoIP tab. Here we need to enter the SIP URI in the format SIP S5200 at, and then the LAN IP address. We'll use 192.168.1.119 in our example setup. We should also verify that the SIP port is set to the default value of 5060. When configuration is complete, press the Write to Radio button at the bottom of the screen to write the configuration to the S5200. Changes will not be applied until this button is pressed. Note that the configuration settings will persist through power cycles. No additional configuration or interaction is needed on the S5200 for running a POLQA voice quality test. Now let's go step by step through how to configure and connect the CMA180, beginning with the TX test scenario, in which the CMA will transmit VoIP packets and receive modulated RF. The CMA180 is configured and controlled through its graphical user interface. This can be accessed via the front panel touchscreen, although a keyboard and mouse can also be used if desired. In addition, the GUI can be accessed remotely over a web browser or using standard remote access clients such as Remote Desktop or VNC. To configure the CMA's IP address, press the Setup Hard key on the front panel and then go to the Remote tab. The other important interface setting is ensuring that the RF connector is set to the default RF COM port. This can be checked using the configuration icon in the main CMA180 GUI. Let's start with a high-level overview of the transmit test scenario. In this scenario, the CMA180 sends voice over IP packets via its LAN interface to the radio under test, here the S5200. This radio then extracts the audio from the VoIP packets and uses this audio to AM modulate its transmitted RF signal. Note that the CMA180 also controls the transmit or push-to-talk function of the S5200. This transmitted signal is routed back to the RF input of the CMA180, which then calculates voice quality using the POLQA algorithm. Let's now go over these connections in more detail. Assuming we've configured the S5200 as described in the previous section, no additional interaction with the S5200 is needed. The next task is connecting the CMA's LAN interface to the radio's LAN VoIP interface. VoIP packets will be sent from the CMA to the S5200 over this LAN connection. The TX out port on the rear of the S5200 is then connected to the RF COM port on the front of the CMA180, and this connection is used to carry the AM modulated RF signal from the S5200 to the CMA. TX POLQA measurements are run under the TX measurement scenario. Simply click on the global toolbar and choose TX under the Analog tab. Once the application is started, press the folder icon to toggle between Split Mode, which shows the generator and analyzer applications side by side, and the Merged Mode, where only one application is visible at a time. This is the default view of the TX test screen. To configure a POLQA TX measurement and send audio encoded as VoIP packets, the generator must be placed into VoIP mode by pressing the VoIP icon. The Routines tab must also be selected in order to configure and run the POLQA test, as well as to view the measurement results. Next, we'll configure the generator. The first parameter is the frequency ID, which must be the same as the frequency ID of the S5200. Note that in ATC applications, the frequency ID and the actual transmit frequency will be different if 8.33 kHz channel spacing is used. Next, we must match the URI to the settings on the S5200. The SIP field should be set to S5200, and the @ symbol should be followed by the VoIP interface address. In our example setup, this would be the address of LAN 1 on the S5200, which we configured to be 192.168.1.119. The AF, or audio frequency generator settings, are configured automatically when the POLQA test is started. Note too that the VoIP, PTT, and AF generator checkboxes must all be individually enabled. Once these boxes have been checked, generator output is started by pressing the play button within the generator window. If the connection is successful, the generator tab LED will turn yellow. The PTT or push-to-talk LED will also turn yellow, and this indicates that the S5200 is transmitting. The generator can be halted by pressing the stop icon. Using these settings, a 1020 Hz tone should be audible from the S5200's built-in speaker or attached headset when generator output is enabled. On the analysis side of the screen, navigate to the Routines tab and set the frequency of the received signal to match the generator frequency. Expected power should also be set at least slightly higher than the expected output power of the S5200. Modulation type must be set to AM. Note that this is not the default value. And finally, method must be set to POLQA. To start the POLQA measurement, press the play button on the right-hand side of the screen. The POLQA audio file, typically consisting of a pair of sentences, should be audible through the S5200 speaker. A pop-up window showing the measurement state and the current measurement will also appear. Note that the number of measurements can be configured by clicking on the configuration icon and then adjusting the statistic count under the POLQA tab. We'll come back to the other parameters in just a few moments. During the test, results will be shown in the pop-up window and also will be used to populate a table in the Overview tab. For each test run, the results indicate the run or measurement number, the timestamp, the name of the audio reference file used, and the MOS value calculated using the POLQA algorithm. In addition to the main Overview tab shown here, there are several other tabs: Eval, Results, and Calibration, and these provide additional information such as the start delay or the transmitted and received audio levels. Now let's return to the POLQA measurement settings screen and discuss some of the other parameters found here. The reference audio file used for the test can be user-selected. Files in various languages are provided in both full-band and super-wideband formats. As mentioned earlier, the number of test runs is defined by the statistic count parameter. Although this presentation shows how to run live or online measurements, measurements can also be made in offline mode by selecting a recorded file containing the degraded audio. The auto calibration checkbox causes the CMA to automatically correct the loudness of the degraded file so that it matches the loudness of the reference signal. This can also be manually adjusted using the gain parameter. And finally, it's possible to specify a measurement delay that can be used to compensate for large delays in the test setup. Note that in most cases, all of these values can be left at their default settings. Next, we'll look at how to configure and run the POLQA RX or receive scenario. In the RX test scenario, the CMA sources an RF signal. This signal is AM modulated by one of the POLQA audio files. The receiving radio converts the demodulated audio into voice over IP packets, which are then sent to the CMA180. The CMA180 analyzes the audio in these received VoIP packets and calculates voice quality using POLQA. As before, our device under test will be a 5200 series ATC radio, with the same configuration as in the TX test scenario. Note, however, that there's one change in the physical interconnection between the CMA180 and the S5200. Although the LAN connection remains the same, the RX test scenario requires that the output of the CMA be connected to the BNC RX in connector on the rear of the S5200. It's important to note that the S5200 uses separate connectors for RF in and RF out. RX POLQA measurements are run under the RX measurement scenario. Simply click on the global toolbar and then choose RX under the Analog tab. This is the default view of the main RX test screen. In an RX POLQA measurement, the generator will be configured to produce an AM modulated RF signal. The Receive VoIP interface and the POLQA test will be configured under the Routines tab. On the generator side, we need to configure the RF settings so that the CMA transmits a carrier at the frequency expected by the radio under test, here our S5200. It's important to note that in the case of 8.33 kHz channel spacing, the frequency ID and the actual transmit frequency will be different. Levels should be appropriately set, and for the S5200, mode must be set to AM. Modulation depth can be set as needed, but 70 to 90% is common. Note that the AF settings, that is the type of audio used to modulate our AM carrier, will be automatically configured when the POLQA routine is started. The generator output will also be automatically enabled by the POLQA routine. Since the CMA180 will be receiving VoIP packets, we also have to configure the VoIP connection between the CMA and the S5200. This is done by going to the Routines tab and clicking on the VoIP icon. Here, we first need to set the VoIP frequency ID to match the RF generator frequency. These can be linked automatically using the Gen RF checkbox. We also have to enter the URI of the S5200 VoIP interface. Here, this would be S5200 at 192.168.1.119. Once these parameters have been configured, we then set the method to POLQA and ensure that input path is set to VoIP. To start the RX POLQA measurement, press the play button on the right-hand side of the screen. As in the TX test, a pop-up window will appear showing measurement state and current measurement result. And as before, the number of measurements can be configured by clicking on the configuration icon and then adjusting the statistic count under the POLQA tab. The POLQA measurement results are shown in a table, and the result of each run are added sequentially. The columns, meanings, and additional information tabs provide the same information as they did in the TX POLQA measurement. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set provides an integrated solution for measuring voice quality using the ITU-T POLQA algorithm. It does this by sourcing and syncing audio signals in 3 different ways: as voice over IP packets, as audio-modulated RF signals, and/or as audio frequency signals. In this presentation, we went step by step through the 2 most important POLQA testing scenarios. The first was transmit testing, in which the CMA sources VoIP packets and syncs an audio-modulated RF signal. The second was receive testing, in which the CMA transmits an audio-modulated RF signal and receives the degraded audio through a voice-over IP connection. In both cases, POLQA analysis is performed using the reference and degraded audio files, and this is done directly on the CMA180, with results displayed immediately after each test. This concludes our presentation, getting started with the CMA180 POLQA testing. If you'd like to learn more about VoIP testing, the CMA180, or air traffic control radios from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.